Hello everyone. In this video, we shall start a new topic under the branch Real Analysis of Mathematics, which is the Riemann Stieltjes Integral. So mainly this topic deals with integration of real valued functions over the intervals on the real line R based on the natural order on R. So precisely here we try to integrate real valued functions whose domain is some closed interval using the natural order on R. So we know that R is an ordered set. So we can define many orders on R. Among those, if I consider the natural order, so which is defined by the less than order, right? So we say A is less than B whenever B minus A is positive. So if I define this relation on R, so it becomes an order, and that order is called the natural order in which the real numbers are arranged. We know that. So the real numbers are arranged from smallest to biggest, right? So using this order, so using the arrangement of real numbers, we'll try to integrate a function which is defined on some closed interval and takes real values. Okay, so this is a topic which mainly deals with integration of real valued functions defined on some closed interval. And how we will integrate? We integrate these functions using the nature of real numbers, using the arrangement of real numbers, how they are arranged from smallest to biggest. So using that nature, using that arrangement, we'll try to integrate these real valued functions. So before jumping into the topic, so first we shall recall so the basics, which is differentiation and integration. So what is differentiation? So differentiation is nothing but rate of change of function value with respect to the change in domain value. So suppose let y is equal to f of x be any function. So precisely, so it is a real valued function defined on some subset A of R. So it is a real valued function of a real variable. Both domain and codomain are subsets of the real line R. Now, differentiation of F is nothing but, so when you give a small change to a domain value, first, if you fix a domain point X, suppose give a increment value for X. So what the change you gave to the value of X, corresponding to that, see the change in function value. So the value at f of x, that is the value at x, and the value at which the next value is, right? So the observing the change in function value with respect to the change which will give to the domain value is nothing but called the differentiation. So we shall illustrate with an example, that with the graph. So suppose the function y is equal to f of x, which I have considered. So suppose say its curve is like this, right? Its curve is like this. Now I'll fix a domain point x corresponding to which the function value is f of x. Now I'll give an increment to the domain value. So x is the initial domain value. So for that, I'll give an increment of delta x. I'll add a value delta x to x. So what will be the resulting value? X plus delta x. X plus delta x. So now corresponding to this x plus delta x, so what will be the function value? It will be f of x plus delta x. Now, what is the change I have given to the domain value? So initially it was x, now it is x plus delta x. So difference of these two will give you the change which I have given, which is nothing but delta x. So with respect to this change, what is the change we can observe in the function value? So initially it was f of x. So this is f of x. So now the later value is f of x plus delta x. So initially it was f of x, now it is f of x plus delta x. So what is the change? It is f of x plus delta x minus f of x. So x was the initial value. The next value which I have taken was considered was x plus delta x. So the change which I have given is delta x. So with respect to this change, the change in the function value I am observing is f of x plus delta x minus f of x. Right. So this is nothing but ratio of change in function value to the change in domain value. Change in domain value. Right. So this ratio is nothing but change in function value to the change in domain value. So now if I consider this ratio for a negligible change, so delta over x was the change which I gave. So if I give a negligible change as delta x approaches to 0, so what this ratio will approach to? What is the ratio of change in the function value to the change in domain value for a negligible change? So that ratio is nothing but dy by dx. So dy by dx is nothing but it is limit delta x approaches to 0 of f of x plus delta x minus f of x by delta x, right? So domain will be, so what is the domain? So domain values are x plus delta x minus x. So the difference is delta x. So this ratio is nothing but the rate of change of function value to the change in the domain value. So this is nothing but called the differentiation of y with respect to x, right? So now we shall come to the integration. So integration is actually of two types. Integration, or we can call it as integral. So it is basically of two types. So first is indefinite integral. The other is definite integral. So indefinite integral is simply the opposite process of differentiation. Hence it is also called anti-differentiation. Anti-differentiation. So it is merely the opposite process of differentiation. So for example, so I'll consider differentiation of x square with respect to x. So differentiation of x square with respect to x is 2x. We know that. So what I can write? So differentiation of x square with respect to x is 2x. So the same I have written in the words, or the same sentence can be written as derivative. So the function what you will get after differentiating the given function is called nothing but the derivative. Here 2x is the derivative of x square. So derivative of x square with respect to x is 2x. 2x is the derivative of x square. 2x is the derivative of x square with respect to x. So when you differentiate x square, you will get 2x. So which is the direct process where we'll call 2x is the derivative of x square. Now go back. Now go back. So as I call 2x is the derivative of x square, I'll call x square is antiderivative of 2x with respect to x. And in place of the word antiderivative, you can use the synonym integral. So I can say x square is integral of 2x with respect to x. So that is integral of 2x with respect to x is x square. So this is the sentence which I'll get at the end. So just if I consider the differentiation process, so differentiation of x square with respect to x is 2x. So go in the reverse direction. So integral of 2x with respect to x is x square. And we symbolize it as, so integral of 2x with respect to x is x square. So this can be written in the symbol, in the notation. So integral, so this symbol is used for integral. Integral of 2x with respect to x is x square. So why we wrote integral of 2x with respect to x is x square? So what is the relation between 2x and x square? So integral is actually the opposite process of differentiation, right? Differentiation. So since when I differentiate x square, I'll get 2x, as since when I differentiate x square, I'll get 2x. So we write differentiation of x square with respect to x is 2x. And using the same idea as when we differentiate x square, we get 2x. We write integral of 2x is x square, right? So we write integral of 2x dx is x square because when we differentiate x square, we are getting 2x, right? So basically, so we can write the definition of integral of a function in this way. So integral of a function is a function whose derivative is the given function. So integral of 2x is x square because derivative of x square is the given function 2x. So we can have one more example. For example, differentiation of log x is 1 by x, right? So this is the symbol for differentiation of log x with respect to x is 1 by x. So in words, I can write this as differentiation of log x with respect to x is 1 by x, right? So this way. Now go back. So integral of 1 by x with respect to x is log x. So symbolized it as integral of 1 by x with respect to x is log x. This is because when you differentiate log x, you will get 1 by x. Right? But so you know that differentiation of a constant term is 0. So differentiation of constant. So differentiation of a constant value with respect to any variable is 0, right? So using this way, so I wrote integral of 1 by x with respect to x is log x, because differentiation of log x is 1 by x, right? So when I differentiate log x, I'll get 1 by x. So I'll write integration of 1 by x is log x. But note that, so when I differentiate log x with respect to x, obviously I'll get 1 by x. So this result holds. But when I differentiate log x plus some constant, so what I'll get, so it is, so a differential operator is linear. That is, I can separate this differentiation of log x plus differentiation of the constant. So differentiation of log x is 1 by x and differentiation constant is 0. So once again, I'm getting 1 by x. That means not only the differentiation of log x is 1 by x, differentiation of log x plus any constant is also 1 by x. So observing this fact, so what I have to write for the integral of 1 by x? According to our definition, what is integral of a function? Integral of a function is nothing but a function whose derivative has to be the given function. So integral of a function andre ಯಾವ ಫಂಕ್ಷನ್ ಅನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಕೊಟ್ಟಿರೋ ಫಂಕ್ಷನ್ ಸಿಗುತ್ತಲ್ಲ, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಂಟೆಗ್ರಲ್ ಆಫ್ ದಿ ಗಿವನ್ ಫಂಕ್ಷನ್. ಸೊ ನಾವು, so integral of 1 by x means it is a function whose differentiation is 1 by x. And we observe that, so log x on differentiation gives 1 by x, and also log x plus k for any constant k also gives 1 by x, and which is a general form. So in general, we write integral of 1 by x dx as log x plus k, where k is called integration constant. And why we write that constant? Because on differentiating log x plus k, we get 1 by x. So not only log x on differentiation gives 1 by x, log x plus k for any constant on differentiation also gives 1 by x. So just to generalize the result, we'll write integration of 1 by x is log x plus k. So this is nothing but the indefinite integral. So indefinite integral is nothing but the opposite process of differentiation. So indefinite integral is nothing but anti-differentiation. So just you have to go in the opposite direction of differentiation. Now we shall come to definite integral. So definite integral means we integrate a function in some definite range. For example, suppose consider function f from the closed interval 0 1 to r defined by f of x is equal to x square. So you know that it is actually a parabola. F of x is equal to x square gives you parabola. So from 0 to 1, I have to map f of x is equal to x square. So and the curve comes like this. So somewhat like this. So 0 to 1. Now, if you integrate f of x dx from 0 to 1, so you know how to integrate it. So integration f of x is nothing but x square from 0 to 1. So integration of x square. Integration of x square is what? So it is the function whose differentiation is x square. So on differentiation, you know that the power of x decreases. So to get x square, what function you have to differentiate? You have to differentiate x cube. x cube. So on differentiating x cube, you get 3x square, but I don't need 3. So consider x cube by 3. So if you differentiate x cube by 3, you will get x square. So integration of x square is x cube by 3. So this is indefinite integral. Now if I apply the, we'll get tell, or we'll refer 0 as the lower limit, 1 as the upper limit. So if we apply the lower and upper limits, so we'll write like this. So we'll first apply upper limit, then lower limit. So it is 1 by 3. And what this value actually give you? It gives the area under the curve. It gives the area under the curve. So basically, definite integral of a function gives you the area under the curve. So what area resides under the curve? So that area value is got by definite integral. So what we recall now, so differentiation. So differentiation means it is the rate of change of function value with respect to the domain value. Next, if we come to the integration, so integration has two types. One is the indefinite integral, the other is the definite integral. Indefinite integral is nothing but the opposite process of differentiation. So what you do in the differentiation process, so just we come back in the reverse way, just we come back to the original. So that is nothing but the integration, indefinite integral. So definite integral means it is related to calculating the area. It is related to calculating the area under the curve, area under the curve. So mainly definite integral deals with the calculation of area. So in definite integrals, we come across single integral, double integral, triple integral like this. So single integral mainly gives you area, double integral gives you surface area, and triple integral will give you the volume. Will give you the volume. So based on the dimension, so single integral, double integral, triple integral. So all these will give you area, surface area, and volume respectively. So this is the basics of differentiation and integration.